Hey guys, welcome to day one of solving CSES Problem Set. Uh, if y'all are seeing this video, y'all probably already seen that I uploaded the daily Code Forces Everyday video. But I decided to start this series to kind of supplement my learning for competitive programming. I was recommended to this problem set by like a trusted source. They have gotten like very good results, and like they said that this problem set has helped him a lot through like competitive programming journey. Simply because if you are familiar with Codeforce's problems at all, they are very verbose and wordy. Like you'll have like they'll make up a story of some person doing something, ton of words. You'll spend like a good minute reading and trying to decipher what the question is actually asking. This problem set supposedly rips all that out and is just straight up questions like given a list, do this string, blah blah blah. And yeah, and the idea is these are like the bare bone versions of most questions or like most pieces of questions. So, for example, if you can kind of rip out everything out of a Codeforces problem and simplify it down to one of these problems, then you kind of have your answer to that kind of problem. You know what I mean? So, yeah, basically, I don't know if I explained that very well, but the TLDR, this is like the words ripped out version of Codeforces problems. And the idea while you're doing a Codeforces problem is seeing if you can relate one of those types of questions to one of these questions in this problem set. And yeah, it should help a lot. It's split up into different sections to help me learn like each different parts of like competitive programming, right? And I'm not too sure where I would be on this list. Obviously, the further down you go, the more difficult the questions probably get, right? So like the earlier ones, they have so many solves, but the later ones have like only a few thousand each. So we'll just work through these, see where it goes. We can look at the introduction, collection of algorithmic programming problems. The goal is to create a comprehensive, high-quality problem set for learning algorithmic programming. Current collection has 400 problems. New problems will be gradually added. Languages: C++, Java, Python. Okay. I/O. In all problems, you should read input from standard input and write output to standard output. After solving a problem, you can view the solutions by other users and try to hack them by giving a test case where a solution fails. Then the new test case can be added to the test data and all submissions will be regraded. Interesting. Books. You can use the problem set together with the recent competitive programming books listed here. I might check those out. And if they look interesting, maybe we can check them out together on the channel. The books discuss techniques and ideas that are useful when solving the problems. Okay, Creative Commons, blah, blah, blah. If you have feedback. Yeah. Okay. So, let's just get started. These videos, I'll try to not make them as long as the Codeforces Everyday videos. Those should be an hour, 2 hours every day. These, just like some supplementary learning, maybe 30 minutes to an hour. Hopefully they're a little bit entertaining to watch and learn, and I do encourage y'all to work these along with me. So yeah, without further ado, let's get started on the first problem. Okay, so weird algorithm. I guess I can like order these a little better. Like this is introductory problems, right? So if I want to like have it in the same order of everything, I can do like folder introductory problems, move this in here, and then let's rename this to like 1 rate algorithm. Although if I do like 11, will it put it out of order? I guess not. I might reorder it later. Okay, whatever. Consider an algo that takes a positive integer n. If n is even, the algorithm divides it by 2. If n is odd, the algorithm multiplies it by 3 and adds 1. This algo repeats until n is 1. For example, the sequence for n equals 3 is as follows. Your task is to simulate the execution of the algorithm for a given value of n input. The only input line contains an integer n. Output print a line that contains all values of n during the algo. Okay, so we take in an input n, so n equals int input. If n is even, the algorithm divides it by 2. So if n mod 2 equals 0, then the algo divides it by 2. So n divided by 2. So if it's even, divided by 2. So we don't have to do single divide because it will always divide fully. If it's odd, so else n times 3 plus 1. This is like a math problem. Some like one of those Veritasium videos. Right? Like Potassium 3 times n plus 1 or whatever it's called. This one is simple math problem no one can solve. I think I've seen this video before. It reminds me of that. But okay, this algorithm repeats until n is 1. So while n does not equal 1, we do this. Okay, your task is to simulate the execution of the algorithm for a given value n. So print n, I guess that's what they want. And let's test it. Come on. Oh, something's not right here. So n is 3. N's not even, so they should 10. N should be equal to 10. Go back through. 10 mod 2 equals 0. Yeah, so, oh, here. N equals n divided by 2. 3. 10. Okay, so the order is a little bit off. We should do this. But this won't output the last variable, right? So we'll do, yeah, so then at the end we can just print 1. And then this should get it. 3, 10, 5, 16, 8, 4, 2, 1. And now they want it like this, so what I can do is I can have an array and then r equals, so we'll have this, and then we can do n dot append, or r dot append in, and then at the end we can just do star r. There we go. And then submit, browse, okay. Programming, CSES, introductory problems, where'd I go? Okay. Oh, it's cool that this one tells you all of the test cases, unlike code forces, so you don't get like stuck. Looks like they all got accepted, so result accepted. Right, and then what do I do next? Analysis. The following code, note that the numbers may be larger. Okay, so this is using C++. I see. And then statistics. It's like fastest code. Looks like it's all in Pascal, and all the shortest code is in Ruby. Interesting. Success rate 95.56%. And there's a queue. I guess this is everyone submitting problems. Cool. Let's just do. Okay, yeah. Okay. Moving on. Missing number. Okay. Should go in the introductory problems as well. You are given all numbers between 1, 2, and n except 1. Your task is to find the missing number. Okay. First number. Okay, so n equals int input. And then second line contains n minus 1 numbers. Each number is distinct in between 1 through n. Okay, so a numbers is equal to list map int input dot split, and then we find the missing number. So what we can do is we can sort it and then iterate through, right? So numbers dot sort, and then for I in range n minus 1, n minus 1. So we can do 1 n minus 1. 1 to n. We can do 1 to n. If we don't even need to sort. We can just do if I not in numbers print I. Break. Um, I wish they added it like a copy and paste the input output. That would be nice. It's just 4. Okay. Let's test like a different case. No, I think this is good. Submit, browse, missing number. TLE. Okay, that's interesting. Okay, so this is O to the N. Right. How can we make this faster? We can try sorting. Sorting is O to the N log N. Not N. What is the time complexity of not? If I in range, so this is in, O to the N, then not in, if length of N minus, so it's like N squared, which is not good. This does remind me of that one code forces problem that we've done where, okay, let me see if I can find it actually. Give me a sec. Programming. Code forces. Uh, oh, that's not what I meant to do. Try new window. There we go. File, open, folder, code forces. Uh, Okay, I don't remember what the question is called, but I do remember saying something along the lines of, like, we can use a set here instead of a list. And set lookup is O of 1, right? Set lookup time complexity. And list lookup is O of n, right? Because sets use a hash table. Sets and dictionaries use a hash table. When an item is added to a set, a hash function calculates a specific predictable memory location when checking for membership. Okay. Lists are just linear search. So, okay, so we can use a set here. Should make it significantly faster. Because this would be O of 1 now. Missing number. Wrong answer. It's Jover. Correct output. Ho, 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 ho. What the hell? What do I output? Empty. Why is my output empty? That's not right. But this is empty too. 2. Correct output is 2. Wait, hold on. In second line contains n minus 1. Oops. If I is not in numbers, so numbers is my set. So basically what my code misses right now is cases where it's like the last number, so 3, 1, 2, we'll miss 3. So if I do 3, 1, 2, yeah, we'll not print anything out. So we should have a print in, or we should track a found variable. It goes false. And then set found. I don't know why I always type found. It's true. And then if found equals false, print in. In or n minus 1? It should be in. So I do 3, 1, 2. 2, 1, 2. Okay. We got it. Let's go. It took me 3 submissions. This shouldn't have taken me that many submissions, but okay, let's see what the analysis is. We can effectively solve the problem using a vector that maintains a Boolean value for each number between 1 and n. Have we seen that number? Then we can find. Okay, so basically they are one passing. Right, they create lists, length n. And then if seen true, and then loop through and find the false. Without a vector or any other data structure. The idea is to first calculate the sum. Oh, that's smart. You can sum it and then subtract all the. You can loop through the numbers list and then subtract everything, and then you can find the final number. That's smart too. Cool. What's the time looking like? 27. Should we do one more? Let's do one more. Repetitions. Okay, it looks like these are in order. So, 3. Oh, that's not what I meant to click. Gotta remember the hotkey is F2 to rename. You're given a DNA sequence, a string of characters A, C, G, T. On the longest repetition in the sequence, this is a max length substring containing only one type of character. The only input line contains. Okay, so n equals stir input. Alright, and then print 1 inch the length the longest repetition. So 0, 4, we can do pref equals in for char in pref equals -1. If char equals pref, max, we're gonna do max rep equals 0, cur rep equals 0. If char equals prev, cur rep plus equals 1. Else prev or cur rep equals 0. Prev equals char. Then max rep equals max rep cur rep. Print max rep. right? 2. That's not right. If char equals prev, max rep equals 0, cur rep equals 0. Let's print char. We should set cur rep equals to 1 because A showed up. It's like A showed up, so this is a first repetition. This is a first repetition. This is a second repetition. This is a first repetition. It's never a 0th repetition. That just doesn't exist. Alright, so I think this is the case. I wish they had more test cases. But we got it. Okay. 3 questions, 30 minutes. That's pretty good for day 1 of the CSES problem set. And I guess if you like this video, subscribe, like and subscribe, and I'll see y'all guys tomorrow. Bye.